Section 15.4, Continuous Deployment with GitOps. Traditionally, continuous deployment is implemented by adding a further step to the production stage of the deployment pipeline. This additional step would authenticate with the target platform, such as a virtual machine or a Kubernetes cluster, and deploy the new version of the application. In recent years, a different approach has become more and more popular: GitOps. The term was coined by Alexis Richardson, CEO and founder of Weaveworks, www.weave.works. GitOps is a set of practices for operating and managing software systems, enabling continuous delivery and deployment while ensuring agility and reliability. Compared to the traditional approach, GitOps favors decoupling between delivery and deployment. Instead of having the pipeline pushing deployments to the platform, it's the platform itself pulling the desired state from a source repository and performing deployments. In the first case, the deployment step is implemented within the production stage workflow. In the second case, which will be our focus, the deployment is still theoretically considered part of the production stage, but the implementation differs. GitOps doesn't enforce specific technologies, but it's best implemented with Git and Kubernetes. That will be our focus. The GitOps Working Group, part of the CNCF, defines GitOps in terms of 4 principles. OpenGitOps.dev. 1. Declarative. A system managed by GitOps must have its desired state expressed declaratively. Working with Kubernetes, we can express the desired state via YAML files, manifests. Kubernetes manifests declare what we want to achieve, not how. The platform is responsible for finding a way to achieve the desired state. 2. Versioned and immutable. Desired state is stored in a way that enforces immutability, versioning, and retains a complete version history. Git is the preferred choice for ensuring the desired state is versioned and the whole history retained. That makes it possible, among other things, to roll back to a previous state with ease. The desired state stored in Git is immutable and represents the single source of truth. 3. Pulled automatically. Software agents automatically pull the desired state declarations from the source. Examples of software agents: GitOps agents are Flux, fluxcd.io, Argo CD, see this link, and Cap Controller, see this link. Rather than granting CI/CD tools like GitHub Actions full access to the cluster or running commands manually, we grant the GitOps agent access to a source like Git so that it pulls changes automatically. 4. Continuously reconciled. Software agents continuously observe actual system state and attempt to apply the desired state. Kubernetes is composed of controllers that keep observing the system and ensuring the actual state of the cluster matches the desired state. On top of that, GitOps ensures that it's the right desired state to be considered in the cluster. Whenever a change is detected in the Git source, the agent steps up and reconciles the desired state with the cluster. Figure 15.8 illustrates the result of applying the GitOps principles.
Figure 15.8. Every time the production stage workflow updates the deployment repository, the GitOps controller reconciles the desired and actual states.
If you consider the 4 principles, you'll notice that we've applied the first 2 already. We express the desired state for our applications declaratively using Kubernetes manifests and customize. And we stored the desired state in a Git repository on GitHub, polar deployment, making it versioned and immutable. We are still missing a software agent that automatically pulls the desired state declarations from the Git source and continuously reconciles them inside the Kubernetes cluster, therefore achieving continuous deployment. We'll start by installing Argo CD, argocd.readthedocs.io, a GitOps software agent. Then we'll configure it to complete the final step of the deployment pipeline and let it monitor our polar deployment repository. Whenever there's a change in the application manifests, Argo CD will apply the changes to our production Kubernetes cluster. Section 15.4.1. Implementing GitOps with Argo CD. Let's start by installing the Argo CD CLI. Refer to the project website for installation instructions, argocd.readthedocs.io. If you are on Mac OS or Linux, you can use Homebrew as follows.
See this code?
We'll use the CLI to instruct Argo CD about which Git repository to monitor, and we'll configure it to apply changes to the cluster to achieve continuous deployment automatically. But first we need to deploy Argo CD to the production Kubernetes cluster. Note: I'll assume your Kubernetes CLI is still configured to access the production cluster on DigitalOcean. You can check that with kubectl config current context. If you need to change the context, you can run kubectl config use context name. A list of all the contexts available can be retrieved from kubectl config get contexts. Open a terminal window, go to your Polar deployment project, Polar deployment, and navigate to the Kubernetes platform production Argo CD folder. You should have copied that folder over to your repository when you set up the production cluster. If that's not the case, please do so now from the source code repository accompanying this book. Chapter 15/15n/polar deployment/platform/production/Argo CD. Then run the following script to install Argo CD into the production cluster. Feel free to open the file and look at the instructions before running it.
See this code?
Tip: you might need to make the script executable first, with the command chmod +x deploy.sh. The deployment of Argo CD consists of several components, including a convenient web interface where you can visualize and control all the deployments controlled by Argo CD. For now, we'll use the CLI. During the installation, Argo CD will have auto-generated a password for the admin account. The username is admin. Run the following command to fetch the password value. It will take a few seconds before the value is available.
See this code?
Next, let's identify the external IP address assigned to Argo CD server.
See this code?
The platform might take a few minutes to provision a load balancer for Argo CD. During the provisioning, the external IP column will show a pending status. Wait and try again until an IP address is shown. Note it down, because we're going to use it soon. Since the Argo CD server is now exposed via a public load balancer, we can use the external IP address to access its services. For this example, we'll use the CLI, but you can achieve the same results by opening Argo CD external IP, the IP address assigned to your Argo CD server, in a browser window. Either way, you'll have to log in with the auto-generated admin account. The username is admin, and the password is the one you fetched earlier. Be aware that you might get a warning, since you are not using HTTPS.
See this code?
It's now time to see continuous deployment in action with GitOps. I'll assume you have been through all the previous sections of this chapter. At this point, the commit stage of your catalog service repository on GitHub, catalog service, should have built a container image. The acceptance stage should have triggered the Polar deployment repository on GitHub, Polar deployment, and the production stage should have updated the production overlay for catalog service with the newest release version, Polar deployment/Kubernetes/applications/catalog service/production. Now we'll configure Argo CD to monitor the production overlay for catalog service and synchronize it with the production cluster whenever it detects a change in the repository. In other words, Argo CD will continuously deploy new versions of catalog service as made available by the deployment pipeline.
See this code?
You can verify the status of the continuous deployment of catalog service with the following command. I have filtered the results for the sake of clarity.
See this code?
Argo CD has automatically applied the production overlay for catalog service, Polar deployment/Kubernetes/applications/catalog service/production, to the cluster. Once all the resources listed by the previous command have the synced status, we can verify that the application is running correctly. The application is not exposed outside the cluster yet, but you can use the port forwarding functionality to forward traffic from your local environment on port 9001 to the service running in the cluster on port 80.
See this code?
Next, call the root point exposed by the application. We expect to get the value we configured for the polar.greeting property in the catalog service production overlay.
See this code?
Perfect. In one step, we automated not only the first deployment but also any future updates. Argo CD will detect any change in the production overlay for catalog service and apply the new manifest to the cluster immediately. There could be a new release version to deploy, but it could also be a change to the production overlay. For example, let's try configuring a different value for the polar.greeting property. Open your Polar deployment project, Polar deployment, go to the production overlay for catalog service, Kubernetes Applications Catalog Service Production, and update the value of the polar.greeting property in the application prod.yml file.
Listing 15.19. Updating the production-specific configuration for the app.
Then commit and push the changes to your remote Polar deployment repository on GitHub. By default, Argo CD checks the Git repository for changes every 3 minutes. It will notice the change and apply the customization again, resulting in a new config map being generated by Customize and a rolling restart of the pods to refresh the configuration. Once the deployment in the cluster is in sync with the desired state in the Git repo, you can check this with Argo CD app get catalog service. Call the root endpoint exposed by catalog service again. We'll expect to get the value we have just updated. If you get a network error, it might be that the port forwarding process was interrupted. Run kubectl port forward service / catalog service 9001, 80 again to fix it.
See this code?
Great! We have finally achieved continuous deployment. Pause for a minute and celebrate with a beverage of your choice. You deserve it. Polar Labs. It's time to apply what you learned in this section to Edge service, dispatcher service, and order service. 1. Using the Argo CD CLI, register each of the remaining applications as we did for catalog service. Remember to authenticate to Argo CD first, as explained earlier. 2. For each application, verify that Argo CD has synchronized the desired state from the Polar deployment repository with the actual state in the cluster. In the case of problems with Argo CD, you can use the Argo CD app get catalog service command to verify the synchronization status, or directly use the web interface available at Argo CD external IP. For troubleshooting Kubernetes resources, you can take advantage of Octant, or use one of the techniques explained in the last section of Chapter 7. Section 15.4.2, Putting it all together. If you followed along and completed all the Polar Labs, you'll now have the whole Polar Bookshop system up and running in a production Kubernetes cluster in the public cloud. That's a huge accomplishment. In this section, we'll give it a try and refine a few last points. Figure 15.9 shows the status of the applications from the Argo CD GUI, accessible via the Argo CD external IP address discovered earlier.
Figure 15.9. The Argo CD GUI shows an overview of all the applications managed via a GitOps flow.
So far, we have worked with Catalog Service, an internal application that is not exposed outside the cluster. For that reason, we relied on the port forwarding functionality to test it out. Now that the whole system is deployed, we can access the applications as intended, via the Edge service. The platform automatically configures a load balancer with an external IP address whenever we deploy an ingress resource. Let's discover the external IP address for the ingress sitting in front of Edge service.
See this code?
Using the ingress external IP address, you can use Polar Bookshop from the public internet. Open a browser window and navigate to IP address. Try logging in as Isabel. Feel free to add some books and browse the catalog. Then log out and log in again, this time as Bjorn. Verify that you can't create or edit books, but you can place orders. When you are done testing the application using the 2 accounts, log out and ensure that you can't access the actuator endpoints by visiting IP address /actuator/health, for example. Nginx, the technology that powers the ingress controller, will reply with a 403 response. Note: if you'd like to provision the Grafana observability stack, refer to the instructions in the source code repository accompanying the book. Great job! When you're done using the production cluster, follow the last section of Appendix B to delete all the cloud resources from DigitalOcean. That's fundamental to avoid incurring unexpected costs.